You did it for like a month in Algebra 1. Do you remember? Maybe remember? Maybe not. It's just when you have 2 lines or more. That's called a system. You could have 2, 3, 4. Anything more than 1 is a system. And when you're being told to solve a system, that is where you are going to find out where those 2 lines or 3 lines or whatever there are, where they meet. Does that sound familiar? So all we're going to do is graph lines and find out where they meet. That's why you had to really know Quiz A to do this, okay? All right, so to be efficient and to do this the easiest way possible, we're going to look at our form, and we're just going to decide, wait a second. Does this look like your equation? Did I print off the wrong one? No, that is not your example 1. Okay, let me fix it. I think yours is fine. I just had to print one off, and mine doesn't match. Y plus, you have this, right? It's a point slope form? Okay. Hopefully that's the only thing that's different. Okay, anyway, I'm going to graph this first one. It's standard form, right? So if I can graph intercepts easily, I should probably do that. So if I want to graph the x-intercept, I cover up the y. I'm looking at x equals 6. So my x-intercept would be 6, 0. Right? Yeah? Remember that? Okay. I'm going to do my y-intercept. I'll cover up my x, and I have y equals 6. So there's my y-intercept. And then I can just draw a line between these. And there we go. There's line 1, right? Okay. Okay, if I want to do the second one, this is point slope form. So let's decide, what is that starting point? What's the point that they gave us in the problem? -4, because remember it's opposite, comma, another -4. Because they're both plus, remember they're opposite. So I'm going to start at the point -4, -4. And I have a slope of 3/4. So that means I go up 3, right 4. 1, 2, 3, 1, 2, 3, 4. And you're going to see where they meet, but keep doing your lines so you fill the grid. 1, 2, 3, 1, 2, 3. And I think that's all I'm going to fit. So that point. Okay, and then that point right there where those 2 lines are meeting, that's your solution. Anyone kind of figure out what point that is? What is that point? Looks like 4, 2. Okay, so when you were in Algebra 1, when they would ask you to solve a system, on this line you would just write that point, right? Well, in Algebra 2, we're going to do this a little differently. Instead of just writing the point, we have to draw these. Remember these? I think we talked about these the other day. Solution sets. Okay? Those little curvy braces, which I can draw a better one on one side than the other. I don't know. They're curly braces. These are called solution sets. Solution sets, and they are required. Okay, you would get points off if you didn't include these. And the reason for that is later in this class, we're going to have solutions that have many parts. Okay, and they would all go inside of the solution set. So we just start off the year with solution sets. Okay, how you know you have to include them in your answer is really simple. You're going to need solution sets if ever the problem says solve. If the verb behind the problem is to solve something, then you're going to put the answer in the solution set. And you'll be reminded of that. I'll keep reminding you all the way through the year. Okay? All right, so that's kind of new to the Algebra 2 part. The other thing that's new is classifying this. Okay? We call this consistent if there is a solution, right? So consistent means there is at least one answer. But let me ask you this. Would these two lines ever meet again after 4, 2? No, it doesn't make sense, right? Because they're straight lines. They're going to go about their separate ways, right? So in that case, intersecting lines like this, they do have an answer, so we are going to call them consistent. Consistent means there's a solution. But there's only one solution, right? So we're going to say consistent, independent. And if you want to read a little paragraph about it, that's below, but it's talking about that example right there. Okay? So that would be considered consistent because there is a solution, independent because there's exactly one solution. Make sense? Okay. And of course, as we go through these examples, we're going to have different cases. So let's look at example 2. Is mine the same as yours? Let's hope. Yes. Awesome. Okay. So this one, again, I have 2 in standard form, right? So if I want to go graph them, and I want to do it the same way as I did this one, if I try to do the x-intercept, I get 12x equals 27. I'd have to divide by 12. Can we divide 27 by 12? No, right? So I'm not going to do that. Instead, I'm going to get this in slope-intercept form. I'm going to take this, and I'm going to get it into y equals. Okay? So this is like that last question on quiz A. We always move the x term to the right side. So when this 12x goes to the right side, will it be positive or negative? Yeah, the 12x will be negative. Now that is still a negative 9y. So negative 9y equals negative 12x plus 27. And then we'll divide by negative 9. Everything gets divided by negative 9. Okay. So I'm left with y equals, the negatives will cancel out. I have 12 over 9, which can be reduced, right? Because we never do this in a decimal, right? Like never, ever, ever. We can divide them by 3, so that'll be 4/3 x. And then 27 divided by negative 9 is just negative 3, right? All right, so we can just graph that, slope-intercept form, right? Start at negative 3 on your y-axis, up 4, right 3. Ran out of room, so I'll go down 4, left 3. Oh, ran out of room. So that's all I can do. Okay, now if I want to do that same thing with the second one, let's see if standard form will work. If I try to do an x-intercept, I have 8x equals 18. So I'd have to divide 18 by 8. Will that work? No. 16 can divide by 8, but not 18. So we got to do the same thing. Get the x on the other side, so negative 6y equals negative 8x plus 18. And then we can divide by negative 6. So we have y equals, okay, negatives will cancel. 8 over 6, what will 8 over 6 reduce to? Mm-hmm. 4 over 3, right? 4 over 3x, and then 18 divided by negative 6 is negative 3. So what do you notice about that equation?
It's the same.
Yeah, it's the same as this one. So there's no need for me to graph it again. All I do is this. I add another set of arrows. So that's just saying two of the exact same line, basically. Okay? All right, when you were in Algebra 1, do you remember what you'd say the answer to that was, the solution? Well, how many points do they meet? All the points, right? So maybe are you used to saying infinite solutions or infinitely many? Yeah, I've heard that today a lot. All real numbers, which technically isn't correct. It's not really correct, but I get why you say that. Okay. Well, if you answer infinitely many solutions, right? That's like me saying, hey, what are your cats' names? And you tell me 2. Like, I asked you what their names were, not how many are there, right? That's weird. So, I'm not really, solution doesn't mean tell me how many answers there are. Solution means tell me what the solutions actually are. Okay? And it's hard to name them because, well, it's this point, and it's this point, and it's this point, and it's this point, and it's all these little points. So here's how we do that in Algebra 2, okay? We start with a solution set, of course, right? We say solution set, all the points x comma y such that, that line means such that y is equal to 4/3 x minus 3. And your solution set. That is telling me the solutions. All of the ordered pairs on that line. Okay? You see the difference between that and infinite? Okay. So that's going to get some getting used to. Yes, you'd be graded on making sure you had all parts to that. Okay? All right. Let's classify it. Is it consistent? Meaning, is there a solution? Yes, it is consistent. Because consistent just means does the solution even exist? And it does. But there isn't one, right? Independent meant there was only one. So logically, if there's more than one, it's the opposite of independent, which is what? Dependent. So this one would be consistent dependent when it's the same line. Oh, and what I also forgot to mention was the fancy name for this. These two lines, whoops, coinciding lines. When they're the same, coinciding, coinciding lines. That means they're the same line. And this little paragraph goes with that example up there. Okay? All right, I bet you can kind of guess what that third example is going to look like. Maybe? Yeah. Hint, it was the joke that was on the board when you walked in. Mm-hmm. Mm-hmm. There was. Yep. Yep. Thanks for noticing that. Okay, let's do the same thing. All right. Can we graph this one with intercepts? Is that going to work? The top one? Oh, wait. Do I even have the same problem as you? Yeah. I do. Fantastic. 4x equals 18. Is that going to give me a good number? Can I divide 18 by 4? No, right? So let's get it in y equals form. So move the x on the other side. 6y equals negative 4x plus 18. Divide by 6, right? Bless you. Y equals, okay, that'll stay negative because there's only one negative. 4 over 6 reduces to what? Negative 2 over 3. X plus 18 divided by 6 is 3. Okay, so we can graph that. Y-intercept of 3. Slope of down 2, right 3. Ran out of room, so do the opposite. Up 2, left 3. Okay. If I do the same thing with the other one, move the x on the other side, so 9y equals negative 6x plus 18. Divide by 9. Y equals negative 2/3 x plus 18 divided by 9 is 2. Yeah, so parallel lines, right? Same slope, but our y-intercept is just different. So I would start at 2 now, and I go down to right 3. So basically every point, you can just think every point is just 1 unit below the line you just drew, because they're parallel, right? Yeah, parallel lines. Okay. So what's the solution? Remember, the solution is the point where the lines meet. So what is that? There isn't one, right? There's no solution. And you used to be able to write the word no solution, but of course we have to do it with the fancy, right? So there's 2 ways you can say no solution. The first way is like this: a solution set with nothing in it. That means here's the answer and there's nothing here. Okay? Or you can do this. That little prohibited sign, like no smoking, no parking, right? That means null set. Empty set or null set. But you can't put the null set inside the empty set, because then you're saying the set of no solution, I don't know. It's just saying it too many times. It doesn't work. So one or the other. Okay? All right. So how would we classify this? Is it consistent? Is there a solution? No. So we can't say it's consistent. So logically, what word means the opposite of consistent? Inconsistent. And that's what this is. Inconsistent. Okay? So every single system that we have will fall into one of these 3 categories: consistent independent, consistent dependent, inconsistent. Okay? All right. Now on the right side of your paper is this place where we're going to kind of put all of our kind of observations of these into this table. Okay? And the rest of this paper does not look like yours, does it? No. Okay. Got it. All right. So just ignore this for now. I printed the wrong notes. So it's okay. We'll deal with it. Let's just do this part. You do have all this is the same though, right? Yeah. Okay. So example 1, okay. Here's mine from my other class. Kind of look like this, right? Those are intersecting lines. They just cross at some point. So I'm just going to draw a little sketch of that. I'm just drawing 2 lines that meet and they have a solution, right? Okay. So what was true about their slopes? Were they the same or were they different? In example 1. Did they have the same slopes in example 1 or were they different slopes? They were different, right? So I'm going to write different slopes. Okay. Doesn't really matter what their intercepts were, because as long as their slopes are different, they're gonna meet at some point, right? Even if you have 2 lines that are like almost parallel but not quite, won't they meet at some point? So as long as their slopes are different, they're going to be intersecting. And the name of this was consistent independent, right? Number of solutions. Well, how many solutions did this one have? 1. It had 1 place, right? It had 1 ordered pair that satisfied both. Right? Okay. Example 2. What kind of lines were in example 2? the same one, right? So a sketch of that could look like a line with two sets of arrows, coinciding lines, right? Okay. What about their slopes? Same or different? Same. What about the intercepts? Same or different? Same. Everything was the same, right? So I'm going to write same slopes and intercepts. Okay. Name of system of equations. So this was called, yes ma'am, consistent dependent. And the number of solutions was infinite, right? There were very many. So I can write infinite here because I'm not being asked what those solutions are. I'm just being asked how many are there. Okay? And then our last one was the parallel lines, right? Okay. And what about these slopes? Same or different? Yeah, parallel lines have the same slope, right? So they have the same slopes. What about their intercepts? Yeah, they have to be different or else they would be the exact same line, right? So this would be same slopes, different intercepts. Okay. The name of the system of equations would be inconsistent. And how many solutions were there? 0. Okay. Let me grab another. Okay. I think this is the same. Okay. So from here on out, my sheet doesn't match yours, right? But you have kind of this situation here, right? Okay. So why we even filled this thing out is so that we can take a look at equations and know what type they are without ever having to graph them. Okay? So all we're going to do is we're going to take a look at each one and we're going to identify the slope of the line and the y-intercept, and then we're going to compare that with what we put up here. Okay? Which I apologize, mine's over here. Okay? Alright, so you got to be really good at picking out slope and y-intercept from an equation, because you shouldn't spend like 8 years doing this work, right? Okay. Look at this first one. Is this standard form? Look really carefully. Is that standard form? No. No, because the x is second and that's a minus sign. It couldn't be negative, right? Okay, but can we get it? If I'm asked for m and b, shouldn't I probably get it into this form? Because that's the form that has m and b, right? Okay, so if we do that, we got to move the x to the other side. So that'll be 4y equals, and will that be positive or negative on the other side? Is it positive or negative right now? It's negative right now. So when it goes to the other side, it'll be positive, right? Okay. 2x plus 6, divide by 4. So we have y equals, and always reduce, right? I would never leave 2 over 4. We should know that 2 over 4 is 1/2, right? 1/2 x plus 6 over 4 is 3 over 2. So the slope of line 1 is 1/2. The y-intercept of line 1 is 3/2. Right? Okay. Let's try the same thing with the second line. Okay? So this one already has x on the right side, which is good. The only thing left to do is to divide by 8, right? So if I just like divide this by 8, what do I have here? Y equals 4 over 8 reduces to what? 4 over 8. 4/8. What's 4/8? 1/2. Minus 12 over 8. You can divide those by 4, right? 12 divided by 4 is 3. 8 divided by 4 is 2. Oops, I forgot my x. That's bad. Y equals 1/2 x minus 3/2. Okay. All right, so the slope is 1/2. What's the b? What do you think? Is it 3/2 or is it negative 3/2? Negative 3/2 because of the minus sign right there. Okay, now we ask ourselves, compare it to our little chart. What is the classification? Same slope, not the same y-intercept. So this one would be inconsistent, right? Same slopes, different y-intercepts. That's what I have. Same slope, different y-intercepts. So this one would be inconsistent. Okay? That's what it wanted us to do, right? Without graphing, is the system consistent independent, consistent dependent, or inconsistent? Okay? Okay, I want you to take a couple minutes and try example 5. Real quick, can you all verify that this is what you have on your paper? Is this the same one? Okay. Awesome. All right. Take a minute. Do this one. I'll walk around and help you and check what you have, okay? After I write it down really quickly. Not right now, because I want you to work on this, okay?
So when there's not a number in front, remember there's always an invisible one. And that's either a positive one or a negative one. So sometimes writing that one in front helps you see like what you have to do. So there is something there that's a negative one y. And that one will be a positive one y. So one of those requires that you do something about it. Just so you remember. And it's just the number. It's not, it doesn't have the x in it. Okay? And then to answer it, then just write it down, you know, like, which one of these it is. You know, like this is on the first one, that one's black or red. Yeah, that's right. And then use what you have here to decide which one it is. Consistent, independent, consistent, independent, inconsistent. All that good stuff.
check what you have with what I have on the board. Try to separate mine by colors. Okay. All right. So the first one, the purple one, I moved the 2x, that's why it's negative. Anytime you move something to the other side, it's the opposite sign, right? What I'm not doing is I'm not showing the minus 2x crossed out. Minus 2x. I'm not showing that step. I'm just moving it, and that's opposite. Okay? All right, but that minus sign sticks with the y. That means negative 1y. So if I want to get y by itself, I would have to divide everything by negative 1. And when you divide by negative 1, all you're doing is switching the sign. So that's why I didn't really write anything. Okay? You all good with why this one is 2x plus 1? Slope of 2, y-intercept of 1. Okay. The second one, move the 2x on the other side so it's negative, and then I just have a positive y, so I'm good, right? Slopes are different, so it's consistent independent. Doesn't matter what the y-intercept is. If the slopes are different, it's consistent independent. Okay. We all good with that? Because you're going to have to repeat this process on your homework. Clear? Moving on? All right. I apologize in advance that the graph on this next example is so small. Okay? Mine isn't because whatever. I had this copy sitting over here. We're going to do our best. Okay? Jet ski rental. Did anybody go jet skiing this past weekend? Labor Day? No? Okay. I don't know if this is legit. Like, I've never rented a jet ski. That seems really expensive. But, I don't know. They're expensive. Okay, so Sandy rented a jet ski for $95 plus $15 per hour. Pauline rented a jet ski for $80 plus $20 per hour. Write a linear system of equations to find the number of hours for which the rental cost is the same. Okay. Write a linear system means write down two equations. If they don't tell us to use x and y, we don't have to use x and y. We can use letters that match our situation. Okay? So what are our variables here? Like, what are we talking about in the problem? Yeah, we're talking about a jet ski rental, but like, what are the things that can change in this situation? Like, what are the verbs, or not the verbs, the nouns here, other than jet ski? What are we talking about? Sandy rented a jet ski for $95. Right? There's one variable. Where's the other one?
Per
Hour. So we have cost and we have hours. Which one is acting like the x? The hours or the cost? The hours. Okay? So we're going to say h is going to equal the number of hours. We could use x if we wanted to, but typically in a application problem, we're just going to use a letter that matches, and then we can have c for cost, right? Okay. So I'm going to write two equations because I have two people, right? I'm going to start with Sandy. Sandy's cost, so C equals for Sandy. Okay, doesn't that kind of look like I set up slope-intercept form a little bit? Like y equals, right? Okay. C is for cost, and I have one equation for Sandy, and I'm going to have one equation for Pauline. Yeah. So this is Sandy's equation. So her cost is going to be equal to, let's do her slope first. Which one of these is the slope? 95 or 15? 15. What's the dead giveaway to that? Per. Right. Y'all remember that? Like per. So this would be 15h plus 95. And then if I want to do Pauline, her cost would be equal to, her hourly charge is 20. Plus, not 95, what is it? 80. All right, there's our system, right? Now we're going to graph it. So we got to go over here and we have to label our axes, right? We don't have x and y, we have h, which is number of hours, right? And we have c, which is cost in dollar amount. Okay? All right, now I know you have a really tiny graph, right? So once we decide on a scale, we are not going to label every single mark, okay? So just so you know, there's 20 tick marks, basically. What do you think is an appropriate scale to go by? 5? If we go by 5s, we'll make it to 100. And I have to start at 95. So why don't we go by 10s? 10 sounds good. So we can start at 0. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So I'm just only labeling every 50. 150. And then 200 at the top. And then for number of hours, I don't really need this to go out to 20 hours, right? We're not really going to rent a jet ski for 20 hours. So maybe we can go in increments of a half an hour. So I'll just label every other tick mark my hour. And that'll take me to 10 hours. Okay. Now if I want to graph it, and I'm going to graph Sandy's first, we have a y-intercept of 95. So 95 is like halfway in between the 90 and 100. And a slope of 15. So that means I would go up $15 every 1 entire hour. So just be careful, because 1 hour spans 2 of these tick marks, right? So I would go up 5, 10 to 15 over 1 hour. There's a point. Then I would go up 10, 15, 1 hour. There's a point. So every other point is going to land like in the middle between 2. So 5, 10, 15 over an hour. And 15 over an hour. So just do the best you can. I know you have a really tiny grid. You know, just do the best we can do. Should I draw an arrow going the other way? Should I do this? Would that make sense? No, I can't have negative hours, right? So I'm only going to go that way. Okay. And now let's do the same thing for Pauline's graph. And Pauline's line will be a little easier to graph. She's going to start at 80. And we're going to go up $20 every 1 full hour. So up 20, right, 1 full hour. 10, 20, 1 full hour. And if you're able to get that on your little paper, you'll see the point where they meet. Okay. All right. So what does it kind of look like? We have a point right there, right? For what number of hours would Sandy and Pauline pay the same to rent a jet ski? What does it look like that point is? Kind of looks like it's 3 something, right? 3 140. But if you didn't know, like let's say your graph, it's too hard to read your graph. Do you know how you can check this in the calculator? This is a good strategy, because if you ever get stuck on a test question, you can use this. You go to y equals, right? You put your first equation in y1, 15x plus 95. You put your second in y2, 20x plus 80. You go to your table, second graph. Okay, and if I'm thinking my answer might be 3 140, I just look. Do I have matching y's for 3? Yeah, 3 140, 3 140, so that's right. Y'all did that in Algebra 1, right? Use tables all the time. Okay, so for what number of hours? 3 hours, and it would cost $140, okay? All right, last thing I want you to do, and I'll come around and check each person's. There are 2 word problems, okay? All you're doing is setting up the system. So just read these and pick the answer choice that matches the word problem. Okay? One of those is pretty simple, one of them's a little trickier. I'll see what you put, and we'll go over the right answer in a couple minutes.
Number 7 was that easier one. What do we think number 7 was? Everybody? Z. Yes, they just didn't put it in self-intercept form totally. Okay. But that last one, 8, you think we know what that one was? Yeah, it's C. S and P were standing for student and patron. Okay? So you just have to make sure in those kind of problems you match the number that goes with the right variable. Because they all kind of look the same, don't they? So just be careful of that. Okay. Put glue on the back of this and put it in your notebook so it's legal to use on your quiz. That's why you have the glue. Y'all put the glue on it and put it in your notebook right now. That's why I have the glue out. If it's not in your notebook, you're not going to be allowed to use it. Emily, you did that? Glued it in? Okay. So, real quick, takes about 8.5 seconds. Slap some glue, put it in the notebook. Okay? Okay, remember what's due tomorrow, worksheet 2 evens. We have a quiz. And if you don't have these notes in the notebook, you won't be able to use them, so make sure those are inside of your notebook.